Alrighty, so today we're going to do the 3-4 evaluating logarithmic functions. And so this is going to be some basically log principles that you can apply algebraically. So, taking a look at what we have here, this is a little hard to read. This right here is supposed to be c times. Anyway, so the idea of logs is that you get rid of exponentials. So that's the whole point. So for instance, as we look at this, and I'm just going to rewrite it because then you'll know that the 10 is there. So the idea is that if you use a log, you actually don't have the ability, or you do have the ability to bring this 3 out front or back again. So basically any power that's ever there can be reduced actually to a multiplier out front. So this phrase actually equals 3 log base 10 of 2. Of course, we can evaluate that. We can just get 10 log base 10 of 2 and then multiply that result by 3. But the idea would be that you could use this rule to rewrite any exponent as actually a multiplier out front. So same thing goes for this one here. It's got a log base 4, but either way, this 3 can actually go out front. So it becomes 3 times log base 4 of x. All right. Our next rule is the product rule. So the idea is that if you have multiplication inside of a log, you can actually split up that log into 2 separate, same base, but different interiors. So r and s has been split. And then you end up having multiplication. So the idea here is that anything that's in this being multiplied, you can go ahead and actually change it into its own log. So we can actually have log of the first number, 25, plus the log of x. And then depending on how you want to write this, you could also do the log of x to the third. Or, again, as we saw in the previous, you can bring that 3 out front as well. So you could have log of 25 plus log of x plus 3 log of x. And really it all just depends. There's not like a set answer, but it all depends on what you're trying to do with each of them. So a lot of times the reason you would expand this into its pieces is because maybe you were also given plus a log 25. And so you wanted to be able to combine those 2 logs together so that you could have a simpler phrase. So either way, the idea is that if you have 2 logs with the same base, everything's multiplying, you can go ahead and split those up into logs that are separately adding. All right, so same thing happens here for log of 9y. Again, that can equal log of 9 plus log of y, and you can also expand it as much as you would like. So for instance, 9 is 3 times 3, right? So we could just do log of 3 plus log of 3 plus log of y, because again, maybe there was some other logs with a 3 in them, and so you wanted to maybe put them all together, or whatever it happened to be. So these don't necessarily have set answers, but they do have this process that you can use. All right, so now we're trying to write things as single logarithms, and this is going to make it feel a lot less like you're not necessarily ending somewhere. So of course, we would have an end because we'd be able to write everything as a single log. So anytime there's a number out front, which there aren't in any of these, you would then be able to bring it into that log as a power, so that's always a good thing to remember. And then as long as everything's the same base, so notice it's not mentioned here, so it's a 10, you can go ahead and then rewrite this all as a single log base 10, or just log of 2 times 4. Be very careful that you don't then bring this plus down in, because it's not plus anymore, it's multiplying once it's inside the log. And so then we can actually just simplify this to log of 8. All right, the next one, again, all addition, and it's all log base 10, so we can write it as a single log with 16 times x squared times y squared. Since all of these are actually squared items, you could do log of 4xy squared. I don't know how helpful that would be, maybe to reduce it so you could bring it out front. So anyway, just ways of rewriting a log. So here's the most basic, putting them in, but then here maybe you had something that could combine. All right, then we have the quotient rule. So anytime that you have, unlike multiplication, now if we have division, you get subtraction. So we have division here of this log, and so we can write it as two separate logs. So log of x squared plus 1, and then subtracting log of x. All right, the next piece is log of 2 over y, and again log base 10, so we're not really going to put a base there. We can just have 2 minus log of y. So it's always the numerator first and then the denominator. All right, so we're going to use that quotient rule to write the expression as a single logarithm. So again, just double check that everything has the same base, which this one doesn't. I remember this example was wrong, so we were supposed to pretend that was actually log of x versus natural log. Otherwise, we can't put them together. So 5 natural log of x, if I'm going to write that so that I can combine it, I'm going to need to bring that power in, so natural log of x to the 5th. And then I'm going to have to bring this 2 in as well, and it does go for both of these pieces, so natural log of x squared y squared. And then because they're subtracted, we can put them in division, so it's a natural log of the whole fraction of x to the 5th over x squared y squared. And so then we have natural log of x to the 3rd y squared. All right. All right, so then we have our next piece here, and we do have a square root inside, which is technically a power. So let's see. No, I don't want to write it like that. So instead we're just going to create it as one log, and it is division. So log of our numerator, x plus 5, over our denominator of just x. So there's not really a whole lot we can simplify inside of there. But if you ever can, like we did in the previous problem, you can maybe simplify your x's or whatever combines. And then let's see, a change of base. So this is very helpful when you have, well, technically just a TI-83 plus calculator. So in the TI-84s, this is not actually as big of a problem, but with your calculator, you can in fact go to stat. No, not stat, math, the math key. And in that math key, if you go down to A, I should have written that over a little bit. You get something that says log base. And when you choose it, you end up getting this option where you can fill in a little box down here, but then also a box inside. So if you have a TI-84 or older, or newer, I guess, the color ones that graph all fancy, or if you're just using the one on that I have links to online, you will be able to have that option. But previous to that, and in fact very helpful, is that you can rewrite a log into any base that you would like. So for instance, if you want to change every single problem into a natural log problem, you can do that because you can change every log base by using this change of base formula. So the idea is that no matter what base you have, I kind of, at least in my head, make this into our first log and then also have a log of 3 because this answer is actually log of 16 over log of 3. So you can kind of see how it already looks like a fraction in the problem itself. So then you just get to do log of the larger number, just the one that's inside the parentheses, over log of the base that was there. And then this last one here, if I wanted to, I could change it to natural log, for instance. So natural log of 10 over natural log of 6. So it doesn't necessarily matter. You could also do log base 8 if you wanted to. So it doesn't matter what base you want to change it to. It's just that a lot of times you will change it to one of these logs because your calculator already has that log base. All right. So they want us to expand each expression, so they basically just want you to make it so that it's a logarithm of as many logs as possible. So if we take a look at what we have here, we have log base 3 for all of these. So the first thing that we can do is make this log of 4 and then log of x. So log base 3 of 4 and then log base 3 of x. Potentially we could do change of base at that point and then have 4 different logs, but that's not really part of what we're doing here. The next one we have subtraction because there's division, so we can do log base 3 of 6x squared minus log base 3 of 3y. But then we can actually expand that so that this is separated by the multiplication and so is that. So if we do that, then we can have, I'll write it down here since we don't have space up there. You can actually have log base 3 of 6 plus log base 3 of x squared minus log base 3 of 3 and then log base 3 of y. Now be careful because this is a subtraction that subtracted everything after it, so we do actually have subtraction here as well. So I'm going to rewrite so that I actually just expand this negative or distribute that negative. As I do that, I'm also going to take any exponent and bring it out front. So we have log base 3 of 6 plus 2 log base 3 of x minus log base 3 of 3, which I'm going to stop right there because log base 3 of 3 is actually 1. So I'm going to rewrite that as a 1. And then minus log base 3 of y. And so this is going to be our final expanded answer. Alright, taking a look at log base 7 here, we've got a lot of things multiplied, and remember that all of these powers can also go out front. So I'm going to do it all in one row here, so log base 7 of 5 plus log base 7, which I'm going to write with a 3 out front. Let's see, plus log base 7 of y, and then with that 2, I'm going to pull that out front and have log base 7 of z. So that's a very long one. And then this last one here with natural log, base 5. That's actually not possible. So whoever wrote that, it's supposed to be log base 5 because natural log is only ever base e. So anyway, if we change it to be log base 5 of x to the 5th, we can actually rewrite that as 5 log base 5 of x, which doesn't cancel anything, but it does allow you to expand it as much as possible. Alright, then they want you to condense each expression, which would mean that they want one log or as few logs as possible. And since these are log base 4, both of them, and there's subtraction, we can write them as log base 4 of 7 over 10 inside. This next one is also log base 4. So before I move, I'm going to put a 5 that used to be out front as an exponent, 7 as well, and a 4 as well. So we will end up with one singular log, base 4, of 2 to the 5th times x to the 7th over y to the 4th. Alright, and then of course you can rewrite 2 to the 5th as 32. So we will erase that. There we go. Then the next log has no base, so we know it's 10. And moving your 2 into the power gives you a log base 10, or just log, of x squared over 11, because that subtraction is 11. This 2 here means that it's an exponent to both of these, so we're going to end up with 20 squared, but also 4 squared. 20 squared is 400, and 4 squared is 16. So we technically have a division here of a log of 16 400ths. Wait, 416ths. Tried to flip that around, and then times 4 to the 0.5. And this is a log base 3. Since these are all numbers, we could go ahead and actually just multiply them out. So 400 divided by 16 is 25. And 4 to the 0.5, 0.5 is actually a square root, so 4 to the 0.5 is 2. And so we do actually have a 50 as the number inside log base 3. Which again, hopefully makes it a lot simpler to look at than that original statement. So we do have an assignment that you can get to. I suppose if you have the textbook, you can get started now or access to that. But that is our notes for today on Chapter 3, Section 4.